Okay students, let us solve the next question from the model question paper. So we need to show that the given vector is irrotational and we need to find its scalar potential. Okay, so that means first we have to show that the curl of this vector is 0. Right? To show that the given vector is irrotational, it is enough to show that the curl of f is 0. So let me call this vector as portion as f1, this is f2, and this is f3. What is the curl of f? The curl of a, the vector a, that is equal to determinant of, so I, j and k. It is dou by dou x, which is dou by dou y, and it is dou by dou z, and it is f1. This is f1, this is f2, and it is f3. Right? So we need to show that this is 0, then only the given vector is irrotational. Actually this is equal to what? This is equal to, so I into, so delete the corresponding column and row, calculate the determinant for this. It is dou f3 by dou y minus dou f2 by dou z minus j into, again delete the corresponding column and row and write the determinant for the remaining portion. So it is dou f3 by dou x minus dou f1 by dou z plus k into, delete the corresponding column and row, it is dou f2 by dou x minus dou f1 by dou y. Right? So let us calculate this first. So we need to calculate the partial derivatives here. So that is equal to I into, so it is dou by dou y of, what is f3? F3 is 3xz square minus y minus dou by dou z of f2. F2 is 3x square minus z. Right? So minus j into dou by dou x of f3. So f3 is 3x z square minus y minus, we need to calculate the partial differentiation of f1. It is 6xy plus z cube. Right? So plus k into the partial differentiation of f2. So f2 is so 3x square minus z minus the partial differentiation of f1, which is 6xy plus z cube. Right? Fine. Now let us mark the constant terms in each partial differentiation. See, here we are doing partial differentiation with respect to y, so 3xz square is constant, y is variable. With respect to z we are doing partial differentiation, so 3x square is constant. So here with respect to x we are doing, so 3 is constant, x square and minus y is constant. Here with respect to z we are doing that, so 6xy is constant, and with respect to x we are doing, so 3 is constant and minus z is constant. With respect to y we are doing, so 6x and z cube is constant. So now we need to differentiate this, right? Okay, so this is equal to, so I into, yes, so here 3xz square is constant, the differentiation of that is 0, minus the differentiation of y with respect to y is 1, minus here 3x square is constant, the differentiation of that with respect to z is 0, minus the differentiation of z with respect to itself is 1, minus j into, here 3z square is constant, so 3z square, and the differentiation of x with respect to itself is 1, minus the differentiation of y is 0 with respect to x, minus the differentiation here 6xy is constant, the differentiation of that with respect to z is 0, plus it is 3z square, right? So plus k into the here 3 is constant, the differentiation of x square is 2x, okay, so minus the differentiation of z with respect to x partially is 0, minus here 6x is constant, the differentiation of y with respect to itself is 1, plus z cube is constant, the differentiation of that with respect to y is 0. So now let us simplify this. Okay, so I into it is minus 1 minus into minus plus 1. So minus j into it is 3z square and minus 3z square, and plus k into here it is 6x minus 6x. So we can cancel these terms now. We can cancel this, and here also cancel. So the whole thing is what? 0. We can say that the curl of the vector A is 0, and hence we can say that the vector A is irrotational. Right? So now we need to find the scalar potential. Okay? So scalar potential in the sense we need to find phi in such a way that so the vector A is equal to the gradient of phi. Right? Yeah. So what's the given vector here? The given vector is it is 6xy plus z cube. Okay, so this is the vector A and this is the gradient. So on equating these two, I can say that look at the coefficient of I here. It is that is dou phi by dou x, that is equal to what? 6xy plus z cube. Right? So and in this question you can also observe one thing here. Look at the coefficient of j. It is 3x square minus z, that is equal to j. So that is equal to 5. That is equal to dou phi by dou y. And here it is 3xz square minus y, that is equal to dou phi by dou z. Right? Now let us calculate the value of phi. Let us integrate with respect to x. That means we are treating y and z are constant, and we are integrating this function to get the function phi. So integration of 6y plus z cube. Okay. So with respect to x we are doing integration, and here we have to write the integrating constant, and here we are treating x and y are constant. So the integrating constant must be a function of x and y, because x and y are constant, right? Yes. Here x is 6 is constant, x is constant, y is constant. So sorry. Here we are doing integration with respect to x. So y and z are constant. Sorry for the inconvenience. So here 6 and y are constant, and the integration of x is x square by 2. Right? And one more correction is needed here. So here the integrating constant must be a function of y and z. Right? So 6y is constant, the integration of x is x square by 2, plus z cube is constant, and the integration of 1 with respect to x is x, plus the integrating constant, which is a function of y and z. Okay? Yeah. So this is nothing but what? 2 1s are 2 3s are. It is a 3x square y plus x z cube plus f1 of y comma z. We have this in one hand. Now we have phi y, that is equal to 3x square minus z. Let us calculate phi on direct integration. Here we are doing integration with respect to y. So x and z are constant. So integration of 3x square minus z with respect to y we are doing integration, and here the integrating constant must be what? Let it be f2. So that must be a function of x and z, right? So this is equal to, so here x and z are constant, so here 3x square is constant, we have 1, so the integration of 1 with respect to y is y, minus z is constant, the integration of 1 with respect to y is y, plus f2 of x comma z. So we have another value of phi here, and here you can observe, you can calculate the value of phi on direct integration with respect to z. So phi equals to, so integration of 3xz square minus y with respect to z we are integrating, and here x and y are constant, therefore the integrating constant must be a function of x and y. So that is equal to, so here x and y are constant, so 3x is constant, the integration of z square is z cube by 3, minus y is constant, the integration of 1 with respect to z is z, plus f3 of xy. This is phi, right? So now you can observe these three functions phi. Okay, we have a same function, but here we don't know what is the function of y and z. But in the second question you can observe one thing here. We have a function of y and z. What is that? It is minus yz. I can say that this f1 must be what? Minus yz. And in the second function you don't have a function of x and z. So in the first thing you can say that xz square is what? This is a function of xz, right? I can write it as what? X into z cube. And in the third function we don't know what is a function of x and y here. So from the first two we can say that 3x square y is what? It is a function of x and y. So finally we can say that the required scalar potential is equal to, so what is the function of x and y? It is 3x square y plus xz cube. What is f1? It is minus yz. So this is the required scalar potential. Thank you.